everybody, welcome back to our neck of the woods. So today's video, hopefully we can finish out the electric in the garage. We can schedule our inspection. Right now we're going to pick up a few more supplies of electrical stuff that we need, and we need to pick up our soffits, and then hopefully we can talk about siding. So stay tuned. Some of the stuff that we're going to pick up right now for the electric is we need some more conduit. I didn't have enough room in my truck when I picked everything up before, and we're going with 3-inch PVC Schedule 40 electrical conduit, and we've got 350 feet. I think I only got about 50 feet on that first run, so we've got the rest to pick up, and they ended up giving me 3 panels, so I've got to return one of these because I only need 2. And they gave me a 200, a 125, and a 100. I don't need the 125 because the 100 is already hung in the garage. And of course, the 125 is not big enough for the house. A few other things that he added on, and I didn't explain this before because I didn't really know what I was talking about, but the wire that we got going from the meter to the house is aluminum wire. I think it's called 3/0. Don't quote me on that, but it's massive. It's over 1/2 of an inch, almost 3/4 of an inch, huge aluminum wire. And the reason why it's so big is because it is aluminum. It ran us about $4 a foot. We had to buy an extra roll of smaller wire that's going to be used for the grounding, but that we ended up getting copper, so it's a heck of a lot smaller. But if we would have went with the 350 foot run for not the ground, but for the main wiring for the 240 volts to the panel, and copper would have cost us around $8 a foot. So we stepped up on the size, but we saved half the price. Now the grounding wire, again, being copper, is a heck of a lot smaller. I would say it's somewhere around 1/4 of an inch in diameter versus 3/4 of an inch for the main wiring. But the way that works is, the reason why there's 4 wires is because from the panel out on the street, it's a 200 amp panel, 240 volts. Because let's face it, your oven possibly, your dryer, out in the garage, you have a 240 outlet. You need 240 volts coming in. So basically you have 2 power wires, and then a neutral, and then a ground. Well, when they get to the electric panel, you can split them going down 2 bus bars that obviously one side of your breaker attaches to a positive and the other side of your breaker attaches to a neutral. But when it splits in the box and goes down, it splits into 110 and 110. That's why most of your house is wired up as 110 volts. But at some times you need 240, therefore you need 4 wires going in to supply the 110, the 110, a neutral, and a ground. Now, one of the other things that we're picking up that I was totally confused on is because that wire is so massive, I'm like, how are we ever gonna put that on the panel? And he's like, oh, I've got to order some special lugs for it because that 3/4 of an inch wire is not just going to slip down into the top of the panel and be able to screw on like that 1/4 inch of copper would. So we need a special lug that will drop down into the hole. That'll get tightened, and then the lug has a bigger adapter. So it's almost like a reducer, if you will, that will attach and will be able to let us use that wire. Now, going from the house main panel to the outside panel in the garage, we can go ahead and use extra little roll that we bought of basically that copper wire that's only 1/4 of an inch, because that panel is only like 10 feet away. So there's not going to be a huge voltage drop, so you don't need a massive wire to supply that. So again, what my father-in-law has to do is run 4 wires through that conduit, through the ICF wall, bring it up through the LV joint into the panel, and then wire it up and pretend that one day those wires will be connected to the panel on the inside of the house. And hopefully the electrician for the county passes us on the garage so that we can button everything up. Okay, so we are back with all of our errands. We went ahead and picked up the rest of the 3-inch conduit that's gonna hold all of our electric going underground. I ordered, or actually even picked up 7 more of the halo soffit lights, because we're gonna end up doing 6 in the front total and 7 in the back. And the reason why there's 7 in the back is because that porch is just a heck of a lot smaller. I also picked up a roll of burial tape, so that way in the future, if anyone doesn't call, you know, 1-800-CALL before you dig, I got some tape so that if you start digging, you'll pull that tape up before you hit the electrical line. And that may even be code, I don't know, but just a roll of, you know, vinyl tape that should be safe for everyone for here in the future, just in case. And then these are these little like lugs I was talking about. So they're aluminum, so they're the same as the wire, so everything stays the same material as it touches each other. But this end here will go down into the electrical box that will fit, which is a 1/2-inch hole. But then as you can see, you've got a 3/4 of an inch hole up here. So it'll sit in the box like this, and then we can run that wire from down or from up through the panel. It will go in there and screw in, and that's how we make a connection with a much larger cable into a smaller hole. And then last at Menards, we went ahead and finally got our soffits. They came in since I ordered them at 2 different times. 1 to just see how they looked, and 2, the one when I made it official that that's what I wanted. So all of our soffit is here. And then we also got 2x6s. Now, the reason why I got 2x6s is this wall, or this lumber here, is only gonna be for the master bedroom wall. We need pretty much a soundproof wall because I work 3rd shift, Aaron works 1st, and the living room is right on the other side of the master bedroom, and we need that wall as soundproof as possible. So soundproof is right around a 65 SC, I'm sorry, an STC rating. I can't remember what it stands for, but it's around a 65. To get a wall that's soundproof at a 65, here's what you would have to do. You would have to use ceiling drywall, which is 5/8. Attach that to a 2x4 wall, put insulation in it, build another 2x4 wall, like an inch away from the first wall, offset your studs so your studs aren't facing each other so you don't get sound travel through wood, through the airspace, through another stud and out. Then you could insulate that wall also, but one wall you could insulate from both sides, but the second wall you won't be able to, or I'm sorry, drywall from both sides, but the second wall you won't be able to drywall on the inside because you can't come in from behind. So again, it would be drywall, a wall, insulation, drywall, another wall, insulation, and then 2 sheets of drywall with an acoustic sealant in between. That just sounds like a crap ton of wall and material and doing all of that for soundproofing. I think if we got into the 50s that we would be safe, and I think I can achieve that with a 2x6 wall. So what we're gonna do is 5/8 drywall, 2x6 single wall, insulation in the middle, and then 2 5/8 pieces of drywall with acoustic sealant. So basically we're getting rid of 1 piece of drywall in that extra wall with the air gap in between. Hopefully it works. Apparently most of the sound travels through the studs, so the insulation does great, whether it's rock wool or fiberglass in between the cavity, but you have more sound travel than going through the drywall, the stud, and then 2 sheets of drywall, which is why you only end up with about an STC rating of about 50 something. But I think that's still good. I think if you look up, a 50 something is still like loud music that you can barely hear. So if I'm watching a movie at night and I've got the surround sound on, I can just turn it down low. It doesn't have to be at max volume that I like would be watching it, you know, if it was in the middle of the daytime and we were watching a movie together. So that's the goal. We'll see if we can achieve it. It's better than nothing, but I think it's a lot better than building 2 walls and doing all of that extra work. So stay tuned. It is freezing and it's dinner time. It's been 50 like the last 2 days, and now all of a sudden it's 32 with a little bit of snowflakes falling. So welcome to Ohio, where you get to see every single season in a day. But we will hopefully get my father-in-law out here in the next 2 days to help with the panel out here, running that smaller copper wire. And then, oh, and we got the insulation quote. I've got to call back and ask him why so expensive, but it literally doubled. I think it's because of the ceiling, so I've got to sit down and look at that square footage. But the insulation quote that we've got for closed cell in the garage is $3,700, $1,000 more than what I thought. So I'll see if spray foam prices have gone up, and I may even get two more quotes from somebody else. So stay tuned. I will be back at it tomorrow, and I'll see you then. All done with that. Sorry the GoPro died and I already buttoned it up. But not to mention, people are always like, do it one way, do it another way. So I left it covered up anyway. And until I get confirmation from my father-in-law that I did it correctly, I don't need to show it and have debates or get yelled at online. But as far as I know, I did it correctly. It's pretty easy. Those switches only have gold screws on them, so there's no spot for a neutral to go on the switches. So all of the neutrals coming from the panel and then coming down through all of the Romex, which there's 3 runs in there, just wire tied all 4 of them together into a twist tie, and now all of the white neutrals are connected. The blacks are all on the bottom switches, so when the light switch is off, power is only going to the bottom screw, And then I did see 2 ways to do it, which I'm sure people are gonna debate this like they did last time with the outlets, and I don't think either way is wrong, but I did do it in a way that I thought was better. And if you look up at the picture right now, you'll see that one of them, you can do it as a daisy chain, and the other picture above right now is in parallel. So by doing them in parallel, like you see in that picture, all of them are powered individually. And then on the top screw, the black Romex wire went to the top screw, and that is then power going to the light source. So when the switch is down, the switch does have power. It is hot. But when you switch the switch up, obviously the power then is transferred up through the switch from the bottom screw to the top screw. And just to perform that test real quick, I'll show you. So we've got an electric meter here, or a power meter. If we turn it on, obviously it's green and it's making no noise. But if we test this thing out and do some static electricity, see, now it turns red and it beeps in your face. So if we go over here to the wire that is going to eventually get tied in with this extra Romex here and go outside, we can test this wire right here, and the black wire is not hot. But the switch is still hot as the black wire is going to the bottom screw on this switch. So when we turn it up, the power now transfers from the bottom screw up to the top screw. And of course, now we've got power going to this light or this wire. Now the ground wires were a little bit more confusing. Once again, switches only have one spot for a ground. So what I did with those is, again, not sure if it's right yet, but I did grab, instead of using those twist ties that take up a heck of a lot of room in the box, which, you know, if you're using one of these, that's a lot of room to take up. Well, on ground wires, you can just use these copper things. They're called splice caps. They're made out of copper, and then you can put all of your wires into there, twist them all together, and then with a special part of your wire strippers, you cramp that down, and it basically just crushes them all together so that they can't pull apart. So I'll wait for him to come over and look at that, and then I'll open up the box and actually show you what I did when he tells me that I did it right. But it works. Obviously, the power's on when the switches are on, and when the switches are off, there is no power. And for right now, how I'm doing it is I just got a 110 plug, crimped all the, twisted all the wires together, and then I can plug it into an outlet. That, not the best way to do it. They actually do make plugs. Usually they're like yellow fat round plugs that you take the casing off. You can put all 3 wires into the casing, screw them down to terminals on the inside, and then you put a cover back over, and then it just acts as a normal like plug source instead of having to do that. And your wires are kept within that housing, and it's a heck of a lot safer. This is only temporary. The panel should be wired up hopefully tomorrow or Sunday, and I don't know how we're going to feed the panel and have me have lights in here, because if he hooks it up to the breaker, I'm not going to have that little pigtail anymore over there. But I don't know. We'll see when he comes over. So I think I already talked about this before, but we can go ahead and spray foam these holes now and cover this wire up. And because you're in between 2 studs, basically, I don't think there's a worry to put a screw through. This one being a little bit more of a danger, because as you're screwing drywall all to these straps right here, you could try and put a screw right here thinking that there's a strap, and you could put a screw right into that. So I almost guarantee the county's gonna make me put some sort of metal plate over here and glue it or kind of push it into the foam or something. And then when we put drywall over that, you obviously can't put a screw through the drywall because you'll hit that metal plate and can't hit that wire. So we'll see what they say about that or give a recommendation. But again, these verticals, not too much of a concern, because there's really no way to hit the drywall because you're in between 2 stud locations. But again, their rules, their way, so we'll see. So I'm gonna leave this for now. We can have power now up in the attic and in the garage just by flicking the switches over there. And we'll wait, hopefully, again, to show you guys how we wire up the box. And hopefully I'll see you guys tomorrow. Till then, I'm gonna just do a little bit of tidying up and stuff. And hopefully we can get this video out to you this weekend. All right, everybody, welcome back. So we got finished up a little late last night. Unfortunately, we're not 100% done. So after my father-in-law left, I remember code changed saying that these breakers may no longer be acceptable and that we have to change them out for arc fault breakers. He went home and looked and was like, yeah, I think you're right. We do have to. And then I was kind of teaching myself what's the difference between all the breakers, and I came across that it says arc fault breakers are needed for dwelling areas, and then of course it listed all the dwelling like locations, and garage isn't exactly on there, but teaching myself about breakers, it just seems like it's a little bit safer to do anyway. So what I quickly learned was those type of standard breakers over there, they do two things. One, they have some sort of thermal heat coupler strip thingy that basically when you start increasing the amperage, the breaker starts heating up. When it senses that the heat's getting too hot, the breaker ends up tripping. So, and that's been done, I'm sure you've done it before. For example, it happens in the camper all the time. If the power wire is running the sump pump in the basement, for example, and we also have the air compressor on and I'm in the house, you know, using the nailer, they'll both run, but only for a short amount of time because you're overloading the 15 amperage breaker that's in the camper. So again, they're both running, but the air compressor then kicks on and you can hear the compressor like start to die, like it's not getting enough juice, and then it eventually kicks on. That's because you're overloading or heating up the breaker, the thermal element in it, and then it ends up popping. The other part of that breaker is it's got some sort of magnet in it, and I think that pops when you increase too much like surge almost. Don't quote me on it, but I think it's more like a surge protector kind of thing. It sees too much electricity too fast, and it basically ends up separating the magnet, and again, the breaker pops. Now, those are all both good and grand, but it doesn't protect against arcing. So what is an arc fault breaker? Well, the arc fault basically sees arcs. So if you were to like rub your feet on the ground, you know, and then go shock your sister, if you got really close with your fingertips and only got that close and you ended up shocking your sister with your fingertip, it detects the arcing. So you didn't actually have to make contact. It's just the arc going back and forth. Now, how do you get an arc? Well, if you didn't screw in one of the wires, like say onto the terminal of the outlet too tight, and that screw ended up loosening up one day, that wire and screw aren't crushed together. They're kind of sitting in there loose. And when you start getting two pieces loose together, you can start getting the electricity to arc. You could also start to rub a wire. The sheathing comes off, and then eventually the wire gets frayed, and eventually maybe the wire actually gets cut because it's moving on something. Well, again, the wire starts to separate from itself a little bit, and you start getting an arc. That breaker is supposed to detect that. So it's just an extra line of defense for your house, your garage, whatever, and I think it's a good idea. The only thing that sucks is those breakers are in the realm of almost $50 a piece, when I think regular breakers are only like maybe 10 or less. So quite a big difference in cost, but you buy them one time, I think you're good for life. So we just have to do it. Now there is a fourth type of breaker that we don't need, but in my research, I was like, oh, that's kind of a cool idea. And it's a breaker that has the first three safety things in it, but they also incorporate a fourth, which is basically a GFI outlet. And what that does, and reasons why I think you would get that, depends on your code where you live. But let's say you've got from the breaker to an outlet, your refrigerator. Only your refrigerator is on that run. And because the refrigerator is in a kitchen, maybe code says that you have to have the refrigerator on a GFCI or have it GFCI protected because it's in the kitchen. Well, if you have some billion-dollar house and you've got this refrigerator that's built into your cabinets, or it's a double door and it weighs 1,000,000 pounds, let's say it ends up tripping the breaker or trips the outlet for some reason, whatever. it's going to be a real big pain in the butt to pull the refrigerator out and reset the GFCI outlet. So maybe where you live, they make it acceptable that you can put a GFCI breaker on instead and then just use a regular outlet. So that way, if it were to ever trip, you just have to go into the basement or wherever your panel is and reset that GFCI breaker because the refrigerator tripped it for some reason. Obviously, I wouldn't be just keep resetting things if it kept tripping, because clearly something's wrong with your refrigerator or something else is going on. But that is a fourth option for a breaker, or technically a third option, but a fourth safety feature that I actually thought was pretty cool. So I'm gonna head to the store right now, and I'm gonna go ahead and get those 3 arc fault breakers. I'm gonna need 2 20s and 1 15. Obviously the 15 for the lights, the 20 for all the outlets, and then again, we need that box mounted here so that we can put another GFCI outlet, a regular outlet, so that it's GFCI protected on that second outlet. That'll be a 20 amp breaker, so that I can have stuff to work with on a workbench here. And I already called the county and we are set up for inspection tomorrow. So again, fingers crossed, I hope we pass. And I have also actually ordered our insulation. So things are changing. I will let you guys know that in another video, but it's gonna be a little bit different than what we talked about before. All right, back from the store, picked up the breakers, and unfortunately they only had 2 types of breakers for my panel. My panel is an Eaton panel by Cutler Hammer, so these are what fit, but I'm not sure why they have 2 different kinds. This kind here is a direct plug and play. The other kind for an arc fault breaker is they have a wire that comes off of here, like a pigtail, and you put that onto the neutral bar in the panel. Not sure why you would want to do that, as this is a plug and play, and they were the exact same price, so why would you want to do that extra work and have an extra wire in your panel if you don't need it? But these are what I went with, and they only had this type here, which if you look on here, there's actually 4 types of protection. So not only is it an arc fault breaker, it's also a GFCI ground fault breaker, and then I'm not sure what CAFIC or CI is, or AFGF is, but I'm assuming that's the 4 type of breakers that we were talking about before. So not only does it have the thermal strip if you overload the amperage, not only does it have probably a magnetic that also will trip it, but you also have the arcing and you also have the ground fault. Now, I didn't mention this before, but a ground fault breaker or outlet, how it basically works is, I believe, again, it's a magnet that looks like a donut. And going through the donut, you've got a neutral wire and a load wire. So you basically got a black and a white. And the current should always be going through that magnet evenly. And if you touch a wire, you've now changed how the wire or the power is going through the wire. You're now creating another circuit, if you will, by touching something, whether it be plugging in something and your finger is touching one of the probes, or you touching your hair dryer wire that's frayed or something. You're now creating a different pathway, and the magnet inside of the outlet or inside of a GFCI breaker, it's going to know that, hey, the power wire or neutral wire, it's changing direction. Something's going on, we need to trip. And the GFCIs can trip in like 40 milliseconds because it only takes milliamperage to stop your heart and kill you, and that's a 20 amp outlet, and the lights are on a 15 amp breaker. So hundreds, if not thousands of more times needed to actually stop your heart and kill you. So to be able to trip that in 40 milliseconds, it's saving your life. So the reason why I also don't mind having the arc fault and ground fault in a breaker is because there is no ground fault for my lights. And the way I thought about that is let's say you've got an old-timey light bulb and it blew, and this used to happen in the day all the time, I remember. If you don't shut the power off to the breaker and you go to grab that light bulb and unscrew it, that light bulb inside of those filaments, they're hot. The filament may be snapped so you no longer have light, but one of those sides of the filament still has power to it. So if you don't somehow create an arc by putting your hand up in there and creating the arc for the breaker to actually fault, you've now just created a ground. You're now touching hot. You're standing on the ground. You're a problem right now and you've got issues. So by having a ground fault breaker on lights where you usually don't have a ground fault breaker, you're only protecting yourself that much more. So while $50 may be overkill for the garage, which I think you still need the arc fault anyway, to go ahead and just add all 4 of them into one breaker, why wouldn't you? It's only that much safer and it's protecting you. So at $49 a piece, screw it, just have them all done. So hopefully this works and you guys can hear me. This is the whole point while I bought this external microphone, that I can talk to you while I'm doing things. But I wanted to tell you guys a quick little story. I almost died when I was like 20 years old. I was working for a heating and cooling company, and part of the heating and cooling company, we would go and do local Walmarts and set up all of their like refrigerator chases and stuff like that. And we also had another crew called Novar. And what the Novar crews did is we did all the breakers and stuff that fed out to the parking lot. So the lights would come on in the parking lot when the sun went down. And I went out to a Walmart and one of the breakers was down and it was stopping all of like part of some of the lights from coming on outside. And I kid you not, the day before, one of our like 65-year-old electricians who had been an electrician for like 30 years always told us, never work on a panel with 2 hands. So unscrew one hand, take the wire out, one hand, remove the breaker, one hand. And I crap you not, I went to remove one of the wires out at a Walmart, out back, in a hut, in like a wooden shed by myself, and I used 2 hands. I took a screwdriver with a metal end, guided it with my fingers right into that panel, and sent 477 volts from my fingers shooting out through my elbow. And luckily, being in a wooden hut, I didn't complete a ground good enough, or else I could have seriously potentially been hurt and or killed, because let's face it, 477 volts. I mean, I was touching, this power wire here, bringing that much in. That would have been 100 amps or 200 amps coming from these wires from a main panel. And for a big business like that, they're probably more than 200 amps. So that was a serious deal. So don't ever work with 2 hands. And these screwdrivers that I've got now, they're electric screwdrivers. They are approved for, it says 1,000 volts. So they've got this plastic rubber sheathing on them. So yeah, technically I guess you could touch this now, but don't. Always try to work with one hand when you're doing stuff with electricity, and make sure that you have the right tools. All right, so the way that this breaker works is it looks like the neutral bus bar that's running down through here. So like this is your neutral with all these screws on each side. It's going down here, shooting down through here, and there's an extra bar in here where it looks like this is attaching to. And then obviously on this internal side, you're actually connecting into here. So it looks like if we just snap that onto there and push, that is now connected, and yeah, the internal metal part is now connecting to here. Now, what I'm not 100% sure on is on these breakers, it says load neutral and power load. So I'm not sure why there's a load neutral on this breaker, but for now, I'm just gonna go ahead and install the black power wire to the load power one, and hopefully that's good enough. So again, not sure why that's on. We'll have to wait for my father-in-law to look at that, or wait for the inspector, and I'll ask him, do you still need a white wire as a secondary to go from here over to here, or what? I'm not sure, but like I said, the back here is already connected to this secondary bar right here. So this breaker is touching neutral, and it is touching load power. Hey guys, real quick, as I was editing this video to get it out to you, 2 things that I learned I wanted to say real quick. So the extra part of those breakers, what basically they're doing, being an arc fault, and the other one was like a CA like arc fault. What that basically is the scenario that I gave, like, is your power wire like is off of a screw and it's detecting that arc. Well, that's only detecting arc on the power wire. The breaker is actually smart enough to know the difference if the arc is happening on like a power to power screw that's not tight, or if a power wire again were to get frayed and separate. But it can also detect if a power wire is too close to a neutral. So let's say like inside of your outlet, your black and your white are somehow connecting, even though they're on, you know, 2 different screws on each side of an outlet. They're smart enough to detect I think series and parallel arcing, which would be like hot to hot or hot to neutral. So that's what those like extra little numbers meant. And the other thing I wanted to say is the reason why you do have a load neutral and no pigtail on this is because who knows what panel you have and who knows what breaker you have, etc., like how you're gonna do the combo. So the reason why you have these breakers with the pigtail would be is if your panel doesn't have this neutral bar here. So if you don't have a neutral bar, you've got nothing to attach the neutral clip to in here. So you've got the pigtail that would go over and attach to here. Again, you would also have this breaker. If you don't have this neutral bar, you would need to add a neutral wire yourself. So you would attach a white wire to here, to the neutral side, and now you're connected. So by us having the newest and latest, greatest panel and this breaker, which is the best option in my opinion, you simply just slap it on, you're connected to the neutral bar and to the power load bar, and you're good to go. So that's the difference of why there's an option on that one and the pigtail wire too. It just, they're just covering you, I guess, for whatever you're buying for what you currently own. As you can see, it is kind of hard to not use 2 fingers, so definitely make sure that you have the right tools, because I always end up stabilizing. And obviously this panel is not hot at all. These wires are going to absolutely nowhere. They're just on the inside of the house. I mean, we don't even have the trench dug yet to bring any power to the house. So there's 1000% no way on earth that anything could be touching us right now. So this is definitely safe to be touching all of this, and I'm not getting hurt. All right, so we've got the 15 amp now to the lights. We've got the 20 amp now going to all of the grounds, and now our outlets are double protected because we've got a GCFI outlet right there. We've got an arc fault and a GCFI breaker now feeding everything. Our lights are now protected. Now the only thing we have to do is mount that box here, and we'll have to hook up this 20 amp so that we have an extra source, and then I think we should be good to go. All right, just had to take a little break, and I had to pull the panel off and take this wood and move it over, because unfortunately the only way I could connect this is they had just 2 plastic pieces. They didn't have a male to male, so as that's a male end right there and that's a female, I didn't see a male to male, so we have to use a little piece of PVC pipe in the middle of these 2, and I'll go ahead and glue them up. But we'll glue that on there like that, and then that will make our connection, and our box will be right there. So if you look back in the video and see why the heck does that look different, is because the wood just went that way about 1 inch, but the panel stayed completely still and didn't move at all. All right, wish me luck for tomorrow. I had to change out the metal box. I'm sure you can make it work. Obviously you do, or else the metal boxes wouldn't be made. But the GFCI is a really fat outlet, and I'm sure I could have put the GFCI over here and then backfed the outlet going this way instead of running everything like this. But the GFCI was hitting like the nipple on the inside here, and that wasn't going to work on the metal box. The metal box is probably an inch, not as deep. So by using one of these ones, it's obviously like over an inch deeper, and not to mention you can still attach it like that, or at least I believe you can, because if you look down the inside one of these boxes, you can see that there's like 4 spots in there that you can put screws into, and then obviously that box is not going anywhere. It's secured as can be to that plywood that I've got up. I mean, it's white. It's not as industrial looking, so if I put a white cover on it, and then when we bring the drywall up here, at least it'll kind of blend in, especially if I paint the plywood there. But as far as I know, everything is done. Everything's hooked up. Everything's ready to go for inspection. I'll probably have to pull these back out so they can take a look. And I went ahead and pulled this one out here so that they can have a quick, easy look down inside. Probably have to do that to the light switches too. But hang tight. We will wait for them to come tomorrow morning, and we'll see if we pass. Wish me luck. Good morning, everyone. So it's like 7:30 a.m. The electrical inspector actually just came and left. He called super early. Good thing though, because he woke me up and said he's going to be here in a half hour, so I was ready for him. But we passed. The panel's good, the soffits are good, all the GFIs are good, although apparently in my county, double GFCI protecting everything is not needed. So because we've got these more expensive GFCI breakers feeding like a GFCI outlet and feeding a GFCI outlet, he says it's not needed. So per him, double protection is not needed. I can go ahead and pop these out, but let's face it, I'm just gonna leave them. He said it's just more of a pain in the butt than anything, because if you're using something and you overload the system and it pops, or well, you wouldn't overload that if you were to hit water or ground contact, however you pop the GFCI, which one's actually popping. Well, here, not a problem, because obviously you can just reset here or open the panel up or open the door up and hit that switch and reset it there. But as the scenario that I was telling you guys yesterday, it ends up being more of a pain in the butt. Like if you have to pull out a refrigerator and get behind there and pop it, or unpop it and reset the GFCI, he's like, yeah, you would just have it at the panel, and if you pop the breaker, you would just go ahead and reset it that way. So cool, good to know in the future. He also said I should have fun with the wiring, and we're gonna go ahead and dig the trench today. Don't know if that's gonna actually happen because I'm relying on someone else, and we all know from my experience, a lot of people do no call, no shows. So we'll see if this afternoon somebody comes out with their little walk behind ditch digger. But if we can dig the ditch today and lay the pipe down in, he said that he is fine with not even running the wire. Just that the ditch is dug, it's at the appropriate depth. He wants to see the conduit down in there, obviously all glued together. So again, fingers crossed that gets done today. I'm probably not gonna have that on video. I'll do that at another one. But the game plan is dig the trench today, throw the pipe down in. He can come back out tomorrow, measure it, and then that way we can sign off and get one more thing done. And then I'm probably going to pull the pipe back out, run the wire through it, since that's easier than having to pull this massive wire. We'll probably pull it on the ground or slip the conduit over the wire. I don't know how I'm gonna do it quite yet, but we need to do this as easily as possible because it's so big and so heavy. But we're up to almost 60 degrees today, so it's not like you're fighting something that's like rock hard and doesn't wanna bend at all. So wish me luck on that, but I am gonna wrap this video up here. We passed inspection, we can put the soffits on, we can start to insulate, we can start to drywall, and then hopefully in the next few videos, you guys will see the garage door install, the soffit install, And I don't know, we'll start building the inside of the house on the master bedroom wall. We got a whole bunch of siding samples. We got James Hardy fiber cement, and we got LP Smart siding. We've got different colors. Erin doesn't want to show you guys yet what we're going with, because I don't think she's 100%, but we'll figure it out. But again, I'm going to wrap this video up here. Thank you all for watching. As always, like, subscribe, please comment, hit us up on Instagram, NeckofTheWoods 2020, if you need to personal message us for anything, and we'll just go from there. So I'm happy to get this video out, happy to pass, and we'll see you guys next time. Take care.